What we have here is a graph of a rational function, and we are going to, or I'm going to help you find the equation of this rational function. So there's a couple of features. The first feature here is that you will notice is that there's a vertical asymptote, and the vertical asymptote happens at x equals 1. That means that the graph does not exist at x equals 1, which indicates that the denominator will be 0 when x is 1. So x minus 1 will be a factor in the denominator. The other thing that you'll notice is that there's a hole here, which means there's another place where the function does not exist. Maybe I should have made that actually a hole like that. It's a hole. There we go. There's no line through that. And it's at x equals, oops, I moved it over, x equals 2 and y equals 4. So that's where the hole is, which means that the denominator is going to be 0 at x equals 2. So there's a second factor in the denominator that we know. It's x minus 2 because of the hole. Now, the hole means that it's a place where it's just a single spot where the function doesn't exist, and so that means that there's an x minus 2 in the numerator as well. So just to recap, if there's an asymptote, it's a single factor in the denominator and no matching factor in the numerator. If it's a discontinuity or a hole, you'll see it both in top and bottom of the fraction. So now I've already dealt with a lot of the features of the graph. There is a x-intercept and a y-intercept at 0. So when the x-intercepts mean that the y value is 0. So this is x equals 0, y equals 0. And the only place the y can be 0 is if the numerator is 0. So the factor in the numerator is x minus 0 because the intercept is at 0. A more efficient way of writing that is without the 0, of course. So here is my equation so far. Now the last thing that we have to talk about is the horizontal asymptote at 2. So here's my horizontal asymptote. I'll make it a little bit thicker here, right there at 2. And if I look at the equation that I've just generated, and I multiply it out, I get x squared minus 2x, and multiplying out the bottom, I have x squared minus 3x plus 2. And if I look at the coefficients of the highest power, so here is the highest power in top and bottom, and there's a 1 out front of both of those. So that would indicate if I left my equation the way it is, the horizontal asymptote would be 1. That's not what I want. I want a horizontal asymptote of 2. So that means that I actually have a factor of 2 out front here in order to create that horizontal asymptote. So my equation, I'm just going to erase this because this was just a little bit of work here. My final equation for this pretty ugly looking graph is 2x times x minus 2 over x minus 1 times x minus 2.